Hi, it's Marc Zienkiewicz, and welcome to the first ever Seed Speaks podcast. This is a special episode recorded live last month in St. John's, Newfoundland at the Seeds Canada annual meeting. Now, this panel was a part of our recent innovation showcase that you may have read on our website or in our July print edition of Germination magazine. This showcase was done in partnership between Germination and Seeds Canada and featured three great panelists. Adam Sturdivant is SORTEX sales representative for Bühler based in Raleigh, North Carolina. Kim Kenward is R&D manager for 2020 Seed Labs based in Nisku, Alberta. And last but not least, Farah Nour is chief science officer for Lucent Biosciences based in Vancouver, British Columbia. Together, we talked innovation in the seed industry and what their respective companies are doing in that space. It's about a 50-minute discussion, so sit back and enjoy the chat. Now, I want to introduce our three guests. Kim Kenward is R&D manager for 2020 Seed Labs based out of Nisku, Alberta, who you can see on the screen there. Adam Sturdivant is Bühler sales representative, SORTEX sales representative for Bühler, which is based out of Markham, Ontario. And last but not least, Farah Nour is chief science officer for Lucent Bio based in Vancouver, BC. Welcome, guys. How are you today?
Thank you.
Thanks for joining us. Now, before we discuss your particular innovations, I want to sort of set the stage with a really big question. We talk a lot at these meetings about making Canada a real player on the world stage and making Canada more competitive and attracting people to Canada to do business. Now, Farah, I don't mean to put you on the spot, but I'm going to put you on the spot for a moment. You're the only person on this stage who was not born in North America. You're originally from Iran, actually, and you've lived all over the world. You've lived in Germany, I understand. You've lived in the United States. You're now based in Vancouver, where you're working with Lucent Biosciences. To kick things off here, Farah, I was hoping you could explain to us a little bit why you chose to come to Canada to work and to innovate, because this is such a huge topic all the time. We're always talking about how do we get people to see Canada as the place to innovate in the ag space. So why did you pick Canada to do this?
Oh, that's an easy
Oh,
question.
don't forget your microphone. Switch. Oh, it's on? Perfect.
Yeah?
There you go.
Okay. Yeah, as you mentioned, I traveled to many other countries, lived there, collaborate with different universities. When I attended to Simon Fraser University 2009 and start working on technologies, developing different technology, totally different area than agriculture, I learned about like opportunities, being entrepreneur here and how you can start, how technology oriented, but is SFU and like government support very new startup company and help them to survive and then grow. So that's one of innovative related reason. The other reason was I really loved Canadian culture and their open-mindedness, their friendship and being kind. So I thought this is the best place to grow my kids and also restart the career and being like working on innovative projects. We started at that time with the 5 co-founders, as you said, well, not that time, a few years later, co-founder, and now we are more than 40 people in our company, and really proud of that. So yeah, thank you, Canada.
Yeah, I think it's a real... Yeah, I think it's a real success story because we're always talking about, how can we attract people here to do business? And we're already doing that. People are already coming here, and you're a prime example of that. And so thank you, Farah. Adam, you're based in Raleigh, North Carolina. Bühler is, as we all know, is an international company. It's actually based in Switzerland. So in other words, your company operates in a ton of jurisdictions around the world. Can you offer us a little insight into what makes Bühler's relationship with Canada unique?
Sure. Yeah, Marc, just want to say thanks for putting this together, and thanks to Seeds Canada. This is my first time in Canada, and I've really enjoyed it so far. To answer your question, with Canada being one of the world's largest exporters of agricultural products, it's important that we have operations here. So we have manufacturing facilities, R&D centers, as well as customer support offices. But aside from the physical involvement, more importantly, the collaboration we have with Canadian partners and customers, it fosters a culture of shared innovations, as well as it allows us to understand and address the specific needs of the Canadian market.
I didn't know this was your first time in Canada.
This is.
Oh, well, welcome.
Thank you.
Kim, your experience with developing new seed tests in Canada is really extensive. Can you offer us some insight in terms of how Canada is already allowing you to innovate in this space? We know there's always improvements that we need to make, but can you talk a little bit about why Canada is a great place to design these new tests?
We have some really good and far-thinking legislation that's in place. So my prime example of this, even when I'm talking on international panels, is always novel traits. I mean, it's flexible, and it allows us to actually do stuff like gene editing without even hesitating and use the past of what we have experienced from transgenics to move over onto the next thing. When I talk to the Europeans, it amazes me how often they've painted themselves into corners in terms of their legislation and just defining everything by the technology. Our concern has been the environment. So we have a strong regulatory structure there. We have a fantastic registration system that's going there. But we also have a good fair degree of room to innovate, because there's actually surprisingly little legislation affecting seed testing labs directly. So you have the purity labs, purity analysts have to be certified, you have the checklist of things that they have to monitor for and watch for, and you have the germination people that have to be certified, and then you have SMUT. But there's very little beyond that. So once you actually get into molecular, we have a lot of room to make what we want to and create new tests there. And as long as we're happy and the clients are happy in terms of the results that are being generated are being useful and workable, then we can actually go ahead and introduce them. And that's a big point in our favor in terms of innovating.
Now, we're going to talk about your 3 innovations now. Specifically, and this will illustrate for all of you exactly what these companies are doing, what Kim is talking about with these new seed tests. I'm going to start with Lucent Bio, your company, Farah. Now, Lucent Bio has attracted huge attention from your industry peers. You raised $19 million in funding from the Protein Industries Canada Supercluster and a group of investors to support Canadian growers' efforts to elevate their sustainability and reduce carbon emissions via a line of micronutrient fertilizers. Now, your latest product is called Nutrios. This is a biopolymer micronutrient seed coating that is non-toxic and plastic-free. First, we're going to play a short 2-minute video about Lucent Bio to kind of illustrate what Lucent Bio is and who's there and what they're doing. So let's roll the Lucent Bio tape.
Today's world is faced with the challenges of climate change and food security. Lucent Bio is pioneering innovative crop input solutions that help decarbonize agriculture and support the transition to sustainability.
Science is the foundation of everything we do. Our team of experts continually pushes the boundaries of sustainable crop nutrition, seeking new ways to optimize plant health.
Lucent Bio is proud to announce an innovative seed coating technology based on biopolymers that are derived from crop residues such as wheat, pea, and oat hulls. Our innovative technology delivers nutrients to seedlings in an innovative way while demonstrating our commitment to a circular economy.
Through extensive research, we have enriched these natural biopolymers with essential nutrients, creating plastic-free, non-toxic, biodegradable seed coating that increase germination rates, promote expansive root growth, and optimize shoot development without the need for safener. The precisely engineered nutrient delivery system activates the microbiome, resulting in an improved bioavailability of nutrients for young seedlings, fostering a stronger crop growth and unlocking yield potential.
Our commitment to advancing crop nutrition using a circular economy approach extends beyond our innovative seed coating technology to also include granular micronutrients and controlled release fertilizer coating. Through strategic partnerships, we actively co-develop custom formulations of our technology with industry partners to boost crop performance and the bottom line in a sustainable way. If you share our vision and would like to join Lucent Bio on this journey,
We invite you to connect with us.
Now, I'm not going to even pretend to know what a biopolymer micronutrient seed coating is exactly. That's why, Farah, I asked you to be part of this panel. Can you explain to us why this is so significant in terms of sustainability?
Sure. So you hit a few most important parameters that we paid attention when we wanted to develop this product. We are not seed provider or seed trader. We are a micronutrient provider. Actually, our product is kind of designed to deliver all these nutrients in a new way. And what is that? During a patented technology, we develop a technology that we bind all these micronutrients like zinc, iron, copper, all these essential microelements to cellulose, fiber, natural polymers. When we say natural polymers, it's just like the residue of food processing company. And something like pea hulls or like rice husk, oat fiber, but for nutrients is specifically, I can tell, like starch or very micronized fiber. So this circular economy model that we are following is food processing company kind of process their seed, the residual or co-product is some fiber, some starch, and then we take that as very low value material, we enrich them with all these nutrients and they become non-water soluble. That's the point. When they are not water soluble, they won't wash off, they won't tie up to the soil, and they stay there until being uptaken by plants. So that's a difference and innovative point between our product versus the rest. But the residue of our product is not chemicals, it's not bioplastic, it's just cellulose, it's just natural product. And we studied a lot and we collaborate with like AFC, we send a product, ask them to send us like mode of action of our product. If it's not water soluble, how does it work, right? And then they told us that the mode of action is through soil microbiome and microbial activity that consume carbon and then these micronutrients and deliver that to the plant. So I can summarize all this like new regulation talk about like sustainable soil, sustainable seed. If you want to code any of the, like your seed and then protect whatever you coded on seed, make them stay longer until seeds are germinated, we offer to test like our product as just natural nutrient and see what happens. We are studying that a lot, and we are seeing a good result on seed early germination and seed establishment. So we are here to introduce that product to you guys and start collaborating with you guys.
Now, Adam, the Bühler SORTEX H SpectraVision, it's a color sorter. That's what we're talking about today in terms of Bühler. Now, a lot of people here know what a color sorter does. We're not going to talk about what a color sorter does, but specifically, you've created an AI engine. Now, we're all hearing about AI, ChatGTP, hear about AI every day, but this is really a really cool engine that allows the SORTEX H to self-adjust, which minimizes the potential for human error, allowing you to run the machine intervention-free. Now, like you say, we're all hearing about AI every day, but that's what I specifically want to talk about is the use of this AI. But first, we're going to run the video for Bühler showing you exactly what the SORTEX H SpectraVision is. So we'll run the Bühler tape. I love that music. So Adam, this use of AI in this machine, we like any new technology, AI tends to be very, there's a lot of panic about it, ChatGTP, the kids are going to use it to cheat on their homework and all this kind of stuff. We all should be worried about AI, but in this case, this is an example of really cool use of AI that's allowing people to do really neat things. Can you talk a little bit about why your use of AI in this machine has a positive impact towards sustainability?
Of course, yeah. So I'll start with a little bit of background. So up until recently, the focus with color sorters is how far can you advance the mechanical components. And when I say that, I say cameras, ejectors, things of that nature. But now we're seeing a shift more on the software aspect, so a bit more on the brain behind the body, so to speak. And reason so is that you can use this to increase the productivity, the seed quality, and reducing the energy usage overall, to tie into that sustainability comment. But aside from that, there's two main points, I'd say. So the energy efficiency and the increased production speed. The AI, it can learn to adapt to specific seed characteristics over time, and that'll optimize the sorting parameters such as shape, color, size, and this will lead to more waste reduction. Now, for the increased productivity, which basically just translates into speed, the AI allows for reduction of the processing time, meeting market demands a bit more efficiently.
Now, 2020 Seed Labs, Kim, you've made significant strides in the field of crop threat identification by developing new tests using advanced molecular and DNA lab techniques. Now, these tests include many industry firsts. You're addressing various threats to crops and seeds, soil, and plants, including Fusarium graminearum, clubroot, Aphanomyces, bacterial leaf streak, and soybean cyst nematode. Again, we're going to play a short video that I believe you actually narrated this video yourself, I think. We'll roll the 2020 Seed Labs tape.
At 2020 Seed Labs, we've been using DNA and RNA-based diagnostic methods for 20 years now, developing and implementing new tests for the agriculture industry. Our portfolio of detections collectively encompass bacteria, fungi, viruses, weeds, and crop plants, to species, pathivars, pathotypes, and variety levels, and on seed, soil, and tissue matrices, supporting disease management, breeding, varietal registration, quality, and export requirements. To ensure meaningful interpretation of results, we maintain close collaborative relationships with our disease diagnostician and purity analyst colleagues, as well as industry partners. Interpretation thresholds and risk ranges are tied to industry standards or agronomic information based on traditional microbiology or other analytical measures. We consult with academic researchers, industry, and government bodies to provide context and ensure confidence in any new test results generated. We collect data for survey mapping of disease presence, reinvest proceeds to support scientific research, and lend our expertise to ISTA and ISO standard development. Tests developed are based on grower industry requests. Candidate markers are validated for sensitivity and applicability against inclusive and exclusive reference materials. Extraction methods appropriate for the sample type and size have also been validated and redeveloped in some cases to accommodate larger subsamples for particular tests. Survey analyses of past season samples often help define expected range and context of results expected. We have also incorporated new technologies as they became available and were suited to give greater meaning to different target or matrix needs. From our pioneering Fusarium graminearum and clubroot qualitative detection by conventional PCR, to sensitive and quantitative qPCR analysis of clubroot and bacterial leaf streak pathogens, to precise linear quantitation by digital PCR, such as used for wheat midge refuge blends. We are proud to have been at the forefront of the molecular revolution in commercial agriculture diagnostic testing, creating and building trust in use of these tests and methods.
Now, innovation, I think, is about risk. And I think when we talk about innovation, we're actually having a risk conversation, right? Like you can't innovate without taking a chance. And all three of your companies have done that. You've taken financial risk in developing new products. You each personally take a risk every day in working to develop products that, you can't be guaranteed these products are going to succeed. You're always taking a risk anytime you innovate, right? Now, Farah, you took a major leap of faith in coming to Canada. Leaving Iran, you went to Germany, you went to the United States, you came to Canada to work and to have your career. Farah, how do you personally, and by extension, Lucent Biosciences, make that determination that a certain path, like developing your Nutrios product, that a certain path is worth pursuing and devoting your time and resources to and taking that risk?
Well, it has been said, if your dream is not scary enough, is not big enough, right? But they forgot to say how scary it should be. And I just went through. But yeah, personally, for me and for everybody who lives like very stable job and like what it already has and leave it for a better future and making something better than what is already have is a risk, right? So for sure, but we work so hard to de-risk that and to make it happen. Uh, really, really hard. So sometimes, especially at the beginning, like if it's 24 hours, sometimes we work like more than, I don't know, 10 or 14 hours per day. It's just a lot. And for the company to de-risk that, we started to make some checkbox. If we want to innovate something, if you want to make a mission and vision for ourselves and set some milestone for ourselves, we needed to make sure is green technology, developing a green technology, is sustainable, is, well, at that time, sustainable wasn't that much highlight, but we wanted to go for clean technology. We were trying to make sure if we solve one problem, we are not making another one, right? Like all these chemicals and polymers that we are coding, or we are using coding seeds, coding NPK, we are making like a slow release coding fertilizer, but we are adding microplastic to the soil, but we are making other problems. So that was our vision and framework and checkbox to make sure we are moving in the right direction. And right now, our technology doesn't produce any wastewater or waste chemicals. It's very highly optimized, because it's like when you go to chemistry world, the residue sometimes makes a lot of problem rather than the real product. But ours is not making extra pollution. It's just clean technology. So yeah, that was the way that we get over that.
Well, and your efforts are getting noticed. What are we looking at here? You're on like looks like a billboard at a bus stop.
Yeah.
What was that for?
So BC Clean Technology came and visited our technology, saw like how our product works, how we are not making, like usually chemical companies make a lot of waste and wastewater, but we are eliminating like leaching of, when we add a lot of fertilizer to the soil, it's not always helpful. It's always, sometimes we just damage the soil and we wash a lot of things in the groundwater and make a lot of pollution, right? But if we make them more like stable in the soil in a clean way, and the residue of your product in the soil is just cellulose, is just like something biodegradable, is a clean technology. So they acknowledged that, they made this one. And I surprised when I was in bus stop and trying to catch a bus, so I took a photo. Yeah.
Adam, the SORTEX H SpectraVision, as I was saying, I was talking about risk earlier, and I mean, we're talking a significant investment of capital to develop this. You know, you put a product like this out there in the public, and you know, especially when you're using new technology like AI, you know, you have to make software updates, all kinds of things. So it's a huge undertaking. And now I know you're an Eagle Scout, and I was I was in Scouts for many years. I got my Queen's Venture Award as well, and so we're kind of we have a lot in common that way. And we both know that the Boy Scout motto is to be prepared. I'm sure many of you know that. How does Bühler stay prepared to manage the real-time use of an innovation like this once it's out there in the public? I mean, it's like, well, in a way, it's kind of like an animal. You release it out there, and now people are using this thing, and there's all kinds of risks involved in that sort of an innovation. How do you guys stay prepared to do that?
Yeah, that's a great question. I like the Eagle Scout plug. That's always good to hear from somebody else. We have some traditional methods like many other companies. We have established processes and strategies in place to manage the real-time use. One of them being customer support and service. So we provide assistance and troubleshooting and maintenance services that customers may encounter. Another is multiple channels of communication. So aside from traditional methods like phone or email or giving me a call when there's an issue with the machine, we offer a couple in-house services, Bühler Insights, remote care, SORTEX monitoring system, a couple different ones like that. Now, another method is scheduling routine maintenance and checking in, as well as software upgrades. So this includes inspections and cleaning and calibration to ensure the optimal performance of the machine. Also, keeping our equipment aligned with the needs of customers by monitoring the market trends, listening to customer feedback, and strongly investing in research and development is another way that we try to stay ready for the real-time use of the machines.
Yeah, so in other words, there's a lot of due diligence that you have to do regarding these products. And we're talking earlier about consumers misunderstanding in the public the image that they have of agriculture. And I think sometimes they don't understand that, a machine like this, there's so much constant due diligence that you have to do as a company to make sure that it's working right, that it's doing what people need it to do. So that's an important message, I think.
Absolutely.
Now, I love this photo. There's Kim. Now, Kim, in the early 1980s, you were an intern in Bethesda, Maryland, at the National Institute of Diabetes, Digestive, and Kidney Disease. As this photo shows, you actually started out in medicine, not in agriculture. So what's interesting to me is the fact that just as much innovation goes into the agriculture space as the medicine space. And people, the general public tends to focus a lot on medicine, but there's just as much that goes on in agriculture. Agriculture is actually the oldest profession, even older than medicine. So one thing I love about what you do at 2020 is you really bring a sense of futurism and urgency to your work. You're not just developing seed tests, but you're creating new ways to test for pathogens, right? To discover these things. So just like in medicine, commercializing a new test comes with risk. There's regulatory risk whenever you're entering into like an uncharted territory in terms of what you're able to do, right? There's risk to the customer, which is why before you commercialize a test, you have to figure out like what levels of a certain pathogen are a danger, right? You don't want to test creating false results or false alarms for people. In your experience, Kim, when developing one of these tests, how do you decide like, okay, this is ready for prime time now? How do you do that?
Our primary goal in every test that we develop is for it to be meaningful and for it to be helpful to the grower. The overall objective is always to have the healthiest seed possible with the least infringement on any other IPs that might be present. So when we go in to look at a test, we're always looking at things like subsample size, how much sensitivity an assay needs, and whether or not how the results that we can generate match with any existing agronomic data that might be present. So when I look at regulation associated with that, there's very few standards associated with it. You have a lot of them in Europe, especially coming from the GM side, but that's actually the relatively easy route to be doing molecular diagnostic development. When you move over to the North American side and you look at the fact that we started from pathogens, it's a much more difficult thing to do. So that's why we end up going back to the traditional standards associated with things like % seed infected. We look at whether or not a seed is a disease is actually a new disease coming in, or if it's something that's already existing and that we have to actually be able to live with it and know exactly what the level is that's going to need to be causing alarm versus actually just calming people and saying, no, this is a normal level that might be present that's out there. So to do that, what we'll do is we'll test something at a sample size that we think is needed. Like for club root, we actually increase the sample size quite a bit. So like your standard DNA extraction kit is around 0.5 grams, and we're up to like 2 cups worth of soil. We also look at the conditions under which we're testing. So there's actually quite a direct loss in the amount of spores that you actually have in club root over the first year. Okay, when your plant goes into the ground, it gets club root, it soaks up all the club root from the soil. And you'd hardly detect any that's present in there, and it all happens to be in the plant. So if you're testing in the soil anytime during the season or right up into the point where the clubroot starts decaying, you're not going to find it. It's all caught up in the plant. So we actually, in that case, we actually came up with sampling instructions in terms of where to go into your field, how to look at where to look for it, and make sure that your sample that you're collecting is most concentrated, and when to look for it. So it's like, don't check when your crop is in the field. Look at the plants instead. See if you can spot that early senescence happening. And don't sample in the fall. Not until after you've had everything start rotting down. And then we actually came back and told people, we want you to dry your soil out, because during that first year, you actually see a substantial drop in the amount of spores that are present that we can detect. And that didn't even show up until 2 years later in the literature, when they actually started figuring out that there was this rather steep drop off before you actually end up with the full 10 years of half-life. But we also were thinking, this is soil. No one's going to be planting in it until the spring, so it needs to dry out. So if we actually dry the sample beforehand, we better simulate the conditions that they're going to be planting under and what the risk is. So once we go through all of that exercise, and we know that something is actually sensitive enough to do what we want it to do, we'll then look at how we can test it in an outside manner. So in that case, we've actually had, I think we set up a blind proficiency test with the University of Alberta, so that they sent us samples and we told them which ones were positive and which were negative for clubroot. And we've done that with other things as well. So like with the varietal ID, we did a blind test with Canadian Grain Commission. Triffid, we go through regular proficiency testing with, again, Canadian Grain Commission. And then we participate in ISTAs all the time and company protocols as well. If we don't have an outside proficiency operator that can do stuff for us, what we quite often do is we go back into our archives and we pull samples from the previous season and just look at it and see whether or not there's something there that's at a level that we should be worrying about, or what's a normal background level or not, versus one that we've inoculated and taken a good hard look at. And we've actually dumped tests based on that basis because the background level was far too high. And we knew that the information that was there was going to be scary to people, and it shouldn't be, because we knew in that year's crop there was no incidences of the disease that we were testing for. So from there, we'll go on to, we've done our proficiencies, and now we'll go out and start testing it on the market. And in some cases, we've actually done soft launches, so that we've gone in and we've done a very keen instruction process to our growers so that they know exactly what the test can provide and what its limitations are. And we will consult with the government agencies that might be looking at that as well, or have some concerns around it, because they're going to end up having to advise people or make recommendations about what to do with those results. And then that will all get incorporated into our technical bulletins, so that when it comes out for a full launch and the results are now available, and we're taking samples from people without the lecture beforehand, then everything should be in place, hopefully, so that there is a number. If we're providing a number, there's a number that's a meaning behind it. And if there isn't a number there, it's because it's probably based on a qualitative basis, because that's all you need at that point, because it's low levels present, and you need to be concerned about its presence rather than its amount.
Yeah. Again, another good message. All three of you and your respective companies have done a lot of work before these products even hit the market to make sure that they're practical, that they're safe, they're viable, right? So I think that's another good message for the public, is that everything we do in this industry, so much work and due diligence goes into it before it even hits the market, before it's a commercial product, right? So we're going to take some questions right away. I want everybody to think of a question. If you have a question, I'm going to kick things off with one of my own. I was just thinking this week that it's been 10 years now since I've been coming to these seed meetings. And there's something about that 10-year mark that's important in our lives, a decade, 10 years. And so along that vein, I wanted to ask you, Farah, 10 years from now, when you think of a product like Nutrios, where do you see that product being? What do you see it being capable of? Can you kind of speculate a little bit on, in 10 years, what your vision is, what you think it might look like or be able to do?
Well, our milestone for 10 years started for now, that we are trying to talk and reach out and connect with a lot of global companies in this area. And one of them is, I just learn about Seed Canada community, and I'm here to getting to know you guys better. I'm learning a lot. And on the other side, we are talking with many other big providers and sending them our product to test out and trying, because there are a lot of regulation. I was in like a few weeks ago in Green Tech Amsterdam, and Europe started to ban using microplastic in agri-tech to make it like more sustainable, effective in 5 years from now. So companies were talking, we don't have solution, we don't have like, what should we do if we don't use like all these coatings that we are doing right now. And they, on the other hand, they were saying, but soil is full of like lots of microplastic, and it's gone to fish, it's gone to our body, it's gone to our plants. So kind of they were talking about that. So we are seeing we have a solution. We are trying to optimize and make it better and better by the time, and introduce that as one of the opportunity as a coding.
Yeah, and this is your first Seed Industry or Seeds Canada meeting, correct, Farah?
This is my first year. I'm one of your new members, and I really learned a lot. Each table that I joined, like the conversation is very valuable. I appreciate that. And hopefully next year I learn more and more from you guys. Yeah.
Adam, 10 years, when you think about Bühler's color sorters, speculate a little bit on what they might be able to do a decade from now that they can't do right now.
Right. Well, there's a couple different things that could occur, but to harp on some of the AI advancements and some of the advanced machine learning and deep learning capabilities, these could improve, meaning the accuracy could improve further as well. So this could also tie into speed and detect a much wider range of characteristics in seeds. Another point is the integration with other technologies, and that's kind of a position we're moving towards now. So this would be meaning, the sorters could speak with other mechanical equipment, Internet of Things, cloud computing, could enable seamless connectivity, as well as remote monitoring and automated decision-making processes. Another point is to enhance the sustainability factor. So this would be aimed at reducing energy consumption, minimal waste, and lowering the overall environmental impact. And so with all of these, they're speculations, but in 10 years, who knows what could happen with the potential advancements with color sorters. There's a few things that were for certain, but with the way the direction's moving now, the sky is the limit.
Kim, 10 years from now, molecular testing, seed testing, where do you see it being? And bonus points if you mention the movie Gattaca.
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 Gattaca, Gattaca.
Ha 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 ha.
What I see happening in 10 years, it isn't so much about what could happen as what needs to happen before we can actually still keep making major advances. There's a lot going on in academics right now where there is a big push towards whole genome sequencing. I do not like that approach, okay? Because you're basically taking a sample and then you're sequencing everything that's on there. And a wheat seed is never a wheat seed. A wheat seed comes with an entire community of other things that are present on it. Do we really need to know what the entire microenvironment is on top of that wheat if we just need to know its variety? And I think the answer is no. If we just need to know whether it's got Fusarium graminearum, that's good, but do we need to know about the sclerotinia that's there that's not even going to affect it? So whole genome sequencing provides too much information when we don't need it. So we need to be, I think it's important to actually think of focusing on the stuff that we want to do. Because the stuff that the answers that we actually need are ones that even the smaller labs can handle. Whereas if you're getting into the whole genome sequencing, you're going to end up having to hand everything over to the big multinationals and no one else, because no one else can afford those kind of level of toys. There's also an opportunity here to be looking at what we're testing, okay? one of the things that holds ISTA back is the need to actually be able to function across multiple levels of technology capability. So there's a reason why we still have a whole lot of disease microbiology tests in there. And some of them are really good, but like Fusarium graminearum, we can only go so far on it with molecular testing because we're still tied to that % seed infected level. And with graminearum, where it's a disease that continues to develop throughout the entire course of the plant, lifetime of the plant, you have different levels of the pathogen present on a given seed. So you can't actually come up with a DNA-based number that's going to match something like a % seed infected. The advantage of molecular is that you can go beyond what biology can do, microbiology can do. So, for instance, clubroot or Phantomyces are both host dependent. You cannot propagate them well outside of the host. So it's a perfect scenario for you to actually be testing it using a molecular test. Same with soil, when you're going to have way too much in there to actually try and clean out and bleach out the stuff you don't want and keep the stuff that you do want. We can also, so those two diseases and other diseases like them, or like bacterial leaf streak, where we're trying to identify a pathovar rather than just the genus or the species that's present there. There's only so far selective media can take you, so we should be using molecular in that case. But we need a new way of actually defining what the levels of concern are. So we can tell you how many genomes of that pathogen might be present there, but we need to know how much is important. And this is where we need to get back to basic agronomy. And one of my real big peeves these days is that we're training lots of molecular pathologists that can't recognize a disease when they get out into the field. And we really need those pathologists to know what they're looking at in terms of the disease, and not only just be like the gene jockey that's capable of looking at the DNA and identifying it. So there's lots of opportunities there for things that we have to resolve and even rebuild the language in terms of how we're doing these diagnoses in order to make them meaningful to other people.
We are going to be doing this again next year, our innovation showcase. You can watch videos on all 8 companies. Just head to our website and watch them. Stay tuned. We're going to be putting out the call again next year for people to apply for the showcase. So please put your innovations forward. We would love to have you participate. Thank you very much to Kim and Adam and Farah. Let's give them a big round of applause. Thanks for listening to the podcast. To check out our 2023 Innovation Showcase and all 8 companies featured, visit germination.ca/innovation-showcase. Have a great day.